So children, today we will discuss about the mixed connections, children. Mixed connections. What is meant by mixed connections means, children, both the series and parallel connection. If ever it is in the circuit, how to find out all the components I will discuss, children. Whatever maybe the questions are possible, all I will try to discuss. See here, children, mixed connections. Okay. In the description, I have given children first question. Please check first question. The question is like this. These both are in series. I hope you are able to understand. 2 ohm, 3 ohm. Again, these both are in series. Please mute your audios. 4 ohm, 5 ohm. They both are in parallel. They both are connected to. They both are connected to. Please check, children. They both are connected to 90 volt battery. Okay, and this is given as A B junction. This is called C D junction. So children, first we will find out the total resistance. How to find the total resistance? You all know very well, children. It's very easy concept also. First, RCD. What is the total resistance RCD? Both are in series. 2 plus 3, 5 ohms because they are in series. Okay, next. RAB, children. Both RAB are also in series, children. 2, 4 plus 5, that is 9 ohms. Now, if ever you see carefully, children, they both are in parallel. They both are in parallel. And what is the formula for parallel? 1 by R is equal to 1 by R1 plus 1 by R2. If I want R total means, try to understand, R total means 1 by RAB, 1 by RCD. So children, 1 by R is equal to 1 by 5 plus 1 by 9. Okay, 1 by R is equal to 45 is LCM, children. 9 plus 5. 1 by R is equal to 14 by 45. R is equal to 45 by 14 ohms is the total resistance. Children, till now I found out only total resistance. Now I will find out total current, children. How to find out total current using Ohm's law? I is equal to V by R. Okay, so V is 90, children. Resistance, how much you got? 45 by 14. 14 goes up. So answer is 28 amperes is flowing in the circuit. Children, in the circuit, 28 amperes of current is flowing in the circuit. Now, this 28, children, after coming here, some current will go here, some current will go here. How much currents will go, we should think. Now, children, if ever you remember, in parallel, I told you potential is constant. I don't know whether you remember it or not, children. In parallel, potential is constant. Means this entire, both of them will have 90 volts. This both of them will also have 90 volts because in parallel, potential is constant. This is 90 means this both will share 90. This both also will share 90. Here also 90, here also 90 because in parallel, potential is constant. Okay, now let me find out how much is the current across CD. I want to find out current across CD, children. Current across CD means I have to write as I by RCD. By I by V by RCD, children, V is constant. In parallel, V is constant. So 90 by RCD is how much, children? RCD 5. So answer is 18 amperes. So children, out of 28 amperes, 18 amperes will go here, children. If 18 is going up, how much will be down? 10 amperes. So anyway, IAB, V by RAB. Try to understand, children. If you do understand and copy or try to do like this sums, then only you become perfect, children. So 10 amperes. So children, in here 10 amperes is coming, here 18 amperes is coming. Out of 28 amperes, how much is dividing? Here 18 is going, here 10 is going, children. So now I2, what will be I2? Current into how much, children? Current into will be 18 because in series current is constant. And what will be current across 3, children? Current across 3 also will be 18 because in series current is constant. And what will be current across 4? Current across 4, children? 10 amperes. And what will be the current across 5, children? Current across 5? 10 amperes. Please mute your audio, son. Please mute your audio. 10 amperes because current is constant. Now we will find out individual potentials, children. Individual potentials. So VAB and VCD, try to understand, children. VAB and VCD, both of them will be 90 volts only, children, because in parallel potential is constant. In parallel, potential is constant. Okay, children, in parallel potential is constant. That's why I'm taking it as same. Now, individually across them, how much? V2. What can I write V2, children? V2 I can write as ICD into R2. Because current across CD is how much? 18. 18 into 2, 36 volt. Okay, those who did not understand, again I'm saying V3 ICD into R3. ICD is how much? 18, because 18 is going here into 3, that is 54 volts. If ever you can see, 36 plus 54 is 90, means 90 is shared as here 36 volt and here 54 volt. 90 is shared as like that. You should understand, children. If you don't understand, it becomes very difficult how to do it. Again, those who did not understand, I am showing V4. V4. What is V4, children? IAB into R4. Okay, IAB is how much, children? IAB is how much? 10 into 4, that is 40 volts. Okay, V5. V5 is how much, children? IAB into R5. IAB is how much, children? 10 amperes. 10 amperes is coming now. 10 into 5, that is 50 volts. Again, those who did not understand, see carefully. 40 plus 50 is 90 volts. I told 90 volts means here full 90, here full 90. But individually, this is taking 40 volts, this is taking 50 volts. Like this, we have to do mixer connections, children. Mixer connections, if you know perfectly series and parallel, then only you can understand this mixer connections also. Okay, so now those who all understood this clearly, children, now we will do power, children. Power across 2, power across 3, power across 4, power across 5. We have 3 different formulas, children. What are the 3 formulas of power I gave, children? Vi, I square R, and V square by R. 3 formulas I have given for power also, children. Using all the formulas we will do, children. I will show you now. Just see, everyone. 1 second. Please copy out, children. Okay, I will be showing powers also, how to find out individual powers. Using all the 3 formulas I will show, children. Okay, first I am using P is equal to VI, children. Okay, P2. What will be P2, children? P2 will be, okay, V2 and IR. V2 into IRCD. Okay, children? P2. Those who did not understand, P5. P5 will be how much? V5 into ICD. Okay, and can anyone tell what is V2? V2 is 36 volts, children. And current across CD is how much? 80. Again, what is potential across 3, children? Potential across, sorry, 3, no, I'm sorry, this is 3. Potential across 3 is how much, children? 54. 54 into 18. So you have to do, children, 36 into 18, 54 into 18. And next one is P4 and P5. P4, what we will write? V4 into IAB. Current across AB is different, children. And V5 will write as V5 into IAB. Whichever formula you use, you will get same answers, children. That is only our verification. Okay. Potential across 4 is how much? 40. 40 into 10, and potential across 5 is how much? 50. 50 into 10 is the current. 500 watts, 400 watts, 18 5s are 99, 72 watts, 36 into 18, children. How much is 36 into 18, children? Anyone got 36 into 18? 648 watts. 648 watts. Okay, children, using one formula I showed. Second formula I'm using, children, I will use this formula and I will show you will get the same answers, see, children. But thing is, how to use them, we have to know. Again, I'm showing P2. P2 is I square R. I square means ICD square. ICD square into R2. And P3 means what, children? ICD square R3. P4 means what, children? IAB square R4. P5 means what, children? IAB square into R5. You should be very, very careful, children, with these numericals. Then only you will understand. ICD is how much, children? 18 amperes. 18 into 18 into 2. 18 into 18 into 3. 10 into 10 into 4. 10 into 10 into 5. Again 500 watts, 400 watts, 972 watts, 648 watts. Same answers you got, children. Check. You got same answers. You have to get, children. That is called perfection. Next, children. If you want, I will show with the third formula also, children. Third formula also I am showing. You have to practice, then only you will understand, children. P2 is equal to V2 square by R2. Okay. P3 is equal to, okay, yeah, let me find out this. P2 is how much, children? P2 is how much? 36. So 36 into 36 by 2. So 2, 18 into 36 is how much? 648 watts. Again, we got the same answer. You can check, children. Again, we got the same answer. Compulsory, you have to get same answer, children. P3. P3 means what, children? V3 square by R3. V3 square is how much? 54 into 54 by 3. Okay, 3 1. How much you are getting, children? 54 only, is it? 54. Got it? 54 into 50, 18. Okay, so 54 into 18 is 972 watts. Same answer you are getting. Please check, children. Okay, next P4. P4 is how much, children? V4 square by R4. That is, V4 is how much, children? V4 is 40. 40 into 40 by 4, again you get 400 watts. Same answers you are getting, children. And last one I am showing P5. P5 means what, children? V5 square by R5. That is, V5 is how much? 50. 50 into 50 by 5. 500 watts. Same question, children. Same question. Thing is, when to use which current and which voltage you should be understand. Then only you can do it, children. In series, current is constant, and in parallel, potential is constant. You should know that. This is mixed connection, children. Mixed connection. Okay. Second one, I think you can do on your own, children. Second one you can do on your own. Third one also you can do on your own. Fourth one we will do, children, because first, second, third are same varieties, children. Just for your practice idea. Fourth one I will do, children. Please go to the fourth question in the description. Link I have given. Go to the fourth question, children. 2 ohm, 4 ohm. Again, 3 ohm, 6 ohm. Okay, children. They all are connected to 20 volt. Same questions, children. Again, everything we have to find out. Okay, so before finding, let's find out resistance, children. These both are in parallel. So what are the conditions I have mentioned? This is A, B, C, D. Okay, children, these both are in parallel. So 1 by RAB is equal to 1 by 2 plus 1 by 4. 1 by RAB is equal to 4 is LCM, 2 plus 1. 1 by RAB is equal to 3 by 4. RAB is equal to 4 by 3, children. This is first term. Now these both are also in parallel, children. You can see that 1 by RCD is equal to 1 by 3 plus 1 by 6. 1 by RCD is equal to 6 is LCM, 2 plus 1. 1 by RCD is equal to 3 by 6. RCD is equal to 6 by 3. RCD is equal to 2 ohms. Now, these both are in series, children. These both are parallel, these both are parallel. But these both are in series. In series, what is the formula, children? R1 plus R2 means RAB plus RCD. 4 by 3 plus 2 is the answer, children. So if you take 3 as the LCM, 4 plus 8, 11 by 3 ohms is the total resistance in the circuit. 11 by 3.
Now, plus 6.
4
plus 6, sir.
Okay, 4 plus 6 means 10 by 3. Yeah, thank you, ma'am. So total current, children, total current. Total current is what, children? V by R total. V by R total. Okay, see how I am doing, children. We also practice like that. 10, 10 by 3, 3 goes up. So total current in the circuit ammeter reading will be 6 amperes. 6 amperes current is flowing in the circuit. Here 6 will be there. Here also 6 will be there. Here also 6 will be there. But after 6 comes here, it will divide. How it will divide? We have to see. Okay, children, to know how it will divide, first we have to find out, children, these both are in series. In series, potential will be shared. In series, potential will be shared. In series, potential will be shared. How they are sharing, I will show you. VAV is equal to IRAV. I, how much we got? 6. RAB, how much, children? 4 by 3. So 8 volts out of 20, this will take 8 volts, children. This will take 8 volts. And if 28 volts this is taking, how much this will have? 12 volts. This will take 12. This both will take 12. If this is 12, this is also 12 volts. This is also 12 volts. If this is 8, this is also 8 volts. This is also 8 volts. Why? Because in parallel, potential is constant. Okay. So VCD, IRCD. I is how much, children? 6. CD is how much, children? CD 2. So 12 volts. I already told many times. So the total potential 20 volts is shared as 8 and 12 by these both junctions. Now we will find out individual currents, children. Individual currents, how current is dividing here. I2, okay, I2, okay, children, I2. How we will find out I2? B by R2, because in parallel potential is constant. 8 by 2 means 4 amperes. Out of 6, 4 amperes is going up, means automatically 2 amperes is coming down. 6 amperes divides as 4 and 2, children. Okay, those who have doubt, you can check. I4 is equal to V by R4, 8 by 4, 2 amperes. Okay, now let us find out I3, children. How to find out I3? V by R3. V is how much, children? V is 12, because 12 is 12, 12, 12. So 12 by 3, that is 4 amperes. And what is I6, children? V by R6, that is 12 by 6, that is 2 amperes. So like this, currents are differing. So here 4 amperes came, here 2 amperes came. They both mixed again, became 6. Again that 6 divided into 4 here and 2 here again. Current, like they divided. Okay, children. So individual potentials I find out, individual currents I found out, everything I found out. Now let us find out powers, children. What are the three formulas of power? P is equal to I square R, P is equal to what are the three? P is equal to VI, P is equal to I square R, P is equal to V square R. When to use what formula is very, very important here in this case. Chalo, children, let's use first formula and find out all the powers, children. P is equal to, first I want across 2. P2 is equal to VI2, because potential is same in both of them. Potential is same in both of them. 8 into 2. That is how much, children? 8 into 2. Current across 2 is 4. Current across 2 is 4. I'm sorry, current across 2 is 4. 32 watts. Those who didn't understand, again I'm saying P4 is equal to VI4. 8 into current across 4 is 2. 16 watts. Those who didn't understand, please at least try to understand here. P3 is equal to VI3. VI3. V is how much, children? 12, 12, 12. 12 into current across 3 is 4. 48 watts. And P4, VI4. 12 into 2, that is 24 watts. Individual powers I calculated using one formula. Now I am using second formula, children, for your understanding. P2, P2, what I can write? I2 square R2. Okay, P4, I4 square R4. P3, I3 square R3. P4, 6, I'm sorry, this is P6, P6, P6. I6 square R6. Try to understand, children. Current across 2 is how much, children? Current across 2 is 4. 4 into 4 into 2. How much? 32 watts. Current across 4 is how much? 2. 2 into 2 into 4. 16 watts. Current across 3 is how much, children? 4. 4 into 4 into 3. 48 watts. Current across 6 is how much, children? 2. 2 into 2 into 6, that is how much, children? 24 watts. Okay, and let me use third formula, children. Third formula also for your understanding. P2 is equal to B2 square by R2. P3 is equal, sorry, P4. P4 is what, children? B4 square by R4. P3, what is P3, children? B3 square by R3. P6, B6 square by R6. Try to understand, children? B2 square. Across this, what is the potential? 8. 8 into 8 by 2. How much, children? 16. 2 fours are 2 fours are 32 watts. Okay. Those who didn't understand, B4. Potential across 4 is how much, children? 8. 8 into 8 by 4. So how much is that, children? 16 watts. Okay. Potential across 3, children. Potential across 3, 12. 12 into 12 by 3. How much, children? 48 watts. Potential across 6 is how much, children? Potential across 6, 12. 12 into 12 by 6, 6 to 72 watts. Am I correct, children? 24, sorry. 24 watts. However, I'm getting same answers that you will get provided you are perfect with the theory. You should know when to use and what. Only two things you remember, children. In series, current is constant. In parallel, potential is constant. If I get 12 volts here, this is also 12, this is also 12. If I get 8 volts here, this is also 8, this is also 8. If I get 20 volts, this is sharing 8 volts and this is sharing 12 volts. That you should understand. In series, potential is shared, but in parallel, potential is same. In series, potential is shared, but in parallel, potential is same. Like this, you have to do, children. And remaining sums, I think you can do on your own, children. Anyone have any doubt, you can ask me now, children.